So now we finally get to the good stuff. We're dealing now with data and process modeling, or in this case, diagrams, right? So let's kind of go through this. I suspect I will probably break this into two videos, and then there's probably going to be a bonus video that I'll sort of go through an example. So here, the purpose now is trying to describe data process or data modeling and process modeling. Now, I want to be careful because we're not really doing data modeling. If you've already done database stuff, you're going to think data modeling is what I typically think data modeling is, which is entities, relationships, and eventually leading to table structure diagrams. But that's not really what this is. This is showing how data flows through a system. And it comes with its own sort of set of symbols and sequence. And so basically we'll be talking about those. One thing I want to make clear about this too is that if you go into some IT shop somewhere and they have nothing like this, then this is a good starting point. If they have something like this, but it's a little bit different, I wouldn't be surprised, because data flow modeling has been around for a while, and I know I actually independently came up with this. And it wasn't until I started teaching this course that I realized, oh, look, people way smarter than me actually had a model like this. This idea is, it comes up all over the place. So anyway, what I'm trying to say is I'm going to show you the classical data flow model, data flow diagrams. And then after that, you can take that and evolve it to however you want to evolve it, as long as people understand what it is when they're reading it. All right, so we'll talk about basically the data flow diagrams. Data dictionaries gets introduced here. That is similar, by the way, to the database stuff that you may have learned in other courses. And then we move on to sort of process. And so we'll probably break right after the data dictionary. And then the next one, we'll probably talk about the process descriptions like structured English, and then decision tables and decision trees. All right, so we're going to be here at the logical model. This is basically showing what the system must do, not how it'll do it. And that's the difference between logical and physical. This sort of shows how let me try it again. What the system must do. So at this point, we don't even know if we're going to even use computers at this point. We just want to know what should the system do? And then when we hit the physical model, which is in effectively the next phase, the system design phase, that's when we'll talk about how it's actually constructed. So we use a whole bunch of graphical techniques, and one of those graphical techniques is the data flow diagram. Data flow diagrams show how data flows through a system, right? There's not necessarily any program logic or processing steps. We're just watching data go through a system. And then the set of DFDs, so it says a set. You're going to see in a minute that a DFD diagram is usually part of a set of DFD diagrams, usually at different levels. So that's what it means by this. And it's basically a logical model. Okay, so we keep emphasizing this again and again, that we're basically showing what the system's got to do, not how it's going to do it. So there are basically four different symbols. And in this case, you got sort of, if you want, two families, Gaines and Sarnson's, and then Jordan. Jordan, by the way, is still alive. I don't know what's going on with Gaines and Sarnson's. But anyway, what you're going to see here is we have, we basically have one for processes, one for the data that's flowing through the system, one for a data store, so this is data stored somehow in the system, and then external entities. And we're going to basically be looking at each of these in detail here. All right, so this is sort of a process symbol. So if you want, by the way, this is sort of this symbol right here, apply payment. And so what they're basically saying is that in a process symbol, you've got to have the name of the process. It has all the business logic in that process. So if this was apply payment, it would have all the business logic somehow in there, or at least it represents the business logic. All right. I mean, we don't know what the business logic is. We just know that it is the verb of apply payment, or they've given some other examples. All right. I like the idea of this being a black box. Again, we don't know what's going on inside of this at this point. We just know that we need something that applies the rent payment, and that's what this process symbol is. And so here's sort of some examples of processes. I'll talk about this in a minute, but here's some processes. Notice they're all verbs. Create invoice, grade student work, calculate gross pay, verify, assemble, right? They're all actions. And we don't know how any of these things happen yet. We just know that these things have to happen. Now, what this slide is talking about are data flows, and that's what these are. Notice these are nouns. And notice that, well, actually, let's talk about the basic part first. So there's an invoice. So a data flow is basically an arrow. It's got direction, and it's got a noun on top, right? A noun on top. So, so I think invoice is a pretty obvious one. Order is another obvious one. Now notice here, your noun can also have an adjective in front. So this is accepted order. A common mistake students make with this is they'll call this thing order accepted or something like that. And that's not cool because order accepted isn't actually a noun. It's actually describing something happening, some kind of action, like the order was accepted. So what you want to try to do is you want to avoid that. You want to basically have a noun, and then if you're going to have an adjective, like for example, gross pay, gross is an adjective that describes pay. Now, obviously, some of these other ones aren't quite like that. So let me just try to get. So here's student grade, graded work. Then you get some other kind of the weird ones like hours worked is obviously together. That would be sort of a noun. But anyway, I hope you kind of get my point here. It's supposed to be basically a noun, and if you got a couple words, it's an adjective describing a noun. Avoid making any kind of process statements here. Your process statements are in here. Grade student work produces graded work and a student grade. Now, the other kind of point inside of this diagram is that you can have a data flow. In fact, you must have a data flow flowing into the process, and you must have a data flow flowing out of the process. And it's okay if you have a data flow going in and two coming out, or two going in and one going out. And this is usually the case over here. It's okay if you have a data flow that goes in, some transformation happens, the data flow goes to the next one, some transformation happens, and then out goes the data. So these are basically all examples of sort of a correct process. Now it does say here too, by the way, that it is possible to have a bi-directional data flow. I'm talking about the double arrowhead. It's possible in theory, like over here, maybe verify order passes the accepted order. Maybe this thing could shoot the accepted order back. So you would see a little arrow right there. All right, so what is wrong with these examples of data flows? It's not so much the data flow that's wrong here, but it's the actual process. This process doesn't have anything flowing into it, and all it's doing is producing information. One thing I want you to imagine about a data flow diagram, data starts outside the system and ends outside the system. It's kind of like water flowing into your house. Water flows into your house, and water flows out of your house. At no point does anything inside of your house produce water, and you definitely don't want water terminating inside of your house. Water flows in, it gets transformed, and then it flows out, all right? So in this case, this guy is producing a flow out of nothing. That's bad. And that's called spontaneous generation. At least that's what the book will call it. Given the holes over here, which I'll talk about in a minute, I would almost want to call it a white hole. But anyway, that's basically spontaneous generation. This guy is a sink, right? Data flows in, but doesn't come out. And you got to wonder, in a system, why would you want data to terminate inside of the process? So, so here again, nothing's coming out. This is called a black hole. And the weird one here, it's not that these don't happen, but you just got to be careful when they do happen. So here the date of birth is coming in. It gets transformed to final grade. That's ageism at its finest, by the way. So you got to wonder, how would date of birth become the final grade? Now, maybe there's some way that makes sense, or maybe this is an incredibly unethical process. So this might actually be what the process is, but you got to be very careful with gray holes. And so that's what that's about. Now, data doesn't flow through the system instantaneously, just like water doesn't flow through the system instantaneously, right? For example, water comes into your house, and sometimes if you got one of these, it's going to sit inside of a water heater, right, and then get heated, and then at some point somebody's going to turn on the tap. Okay, so there's your water example. Same deal with data. As data flows through your system, it's probably going to stop and park somewhere. Now, for you database people, this is probably a database. But it doesn't have to be a database, but it probably is a database, where an order would go and be stored in a database, and then later on someone will pull it out of that part of the database and transform it and move it to something else, like accounts receivable, for example. But this doesn't have to be a database. In the, I think in a previous discussion, I had said something to the effect of how data flow diagrams could easily have been drawn out in like an 18th century office, where somebody would basically come in with an order and put it onto the person's desk in their actual inbox. That would have been a data store, because it would have sat there until the clerk then picked up the order, did whatever they had to do, and then put it in their outbox, and then someone would take it somewhere else. So the data store is just data that is stored in the system. And a common mistake student makes is that they don't put those in the diagram. And what I want you to imagine is, if you don't have a data store, what you're saying is the instant someone outside the system gives a piece of information into the system, it pops right back out. Now, a D2L example would be your grade, right? So you submit your homework, it sits in a Dropbox, and then I come and I pull the homework out, I grade it, I put the grade ultimately onto the system, and then you come and retrieve the grade. There's at least 2 data stores there. All right, so that's what a data store is. It's something that that stores the information inside of your system. So here they've got a process that basically passes data flow into a data store. By the way, these are all using Gaines and Sorensen symbol sets. But anyway, so there's it goes into the data store. The data store then, it sits there until this process, prepare deposit, pulls it out. This guy here, create invoice, pushes an invoice into the data flow. Post payment sometime later, pulls out the invoice detail and pushes back the payment detail. And then here you've got, again, sort of a push, and then sort of a pull and a push. All right, so that's awesome. What's wrong with these? This is the most obvious what's wrong with these. This guy here, you can't have a data store talk to another data store. There has to be a process between. All right, there has to be a process between. So it's like that inbox, outbox example I sort of brought up. Someone has got to basically, some process has got to come and take the order from that person's desk and move it over and put it somewhere else. The desks don't talk to each other. Just like here, when you put your homework into the Dropbox, and then, so if that's your Dropbox and that's the grade, some transformation has to happen where I pull the homework, transform it to a grade, and push it into the grade Dropbox or the grade book or whatever it's called. All right. So there's got to be a process between these two. You can't have a data store talking to another data store. With post payment, what's the problem here is that this is totally fine. I don't like this diagram that much. This is totally fine. What's wrong is that nothing's pulling anything out of the data store, right? Something's got to come out of the data store, because again, otherwise this is like a sink, and it's like water sitting inside of your home, right? If what happens when water sits in your hot water heater, like it never gets pulled out, eventually it rusts and busts, right? So that's what I'm going to say here. This is basically wrong because it's not leaking, it's not pushing any water out. There's no data flowing out of it. And what's wrong here is that this thing is creating data. This is something inside of the system. So there should be something feeding that data flow. All right, we're almost finished the bits, and then you'll actually see one of these things in action. So entities. Entities are something that exists outside the system. Oh, by the way, again, forget everything you know about database language, because the word entity here is, although it's similar, it's going to be different enough to mess you up. So an entity is something outside the system. You are an entity in the world of D2L. I am an entity in the world of D2L. We both exist outside the system. If the system was to shut down tomorrow, we would still exist. So that's what an entity is. An entity is outside the system, and it's represented by a square, okay? We are the ones that create and receive information from the system of D2L. So in this case, a customer exists outside of D2L, whatever this is. The customer is the origin or the termination of the data. So they basically put a payment in, and then it would flow through the system. Here, we have a process that's going to receive something from outside and push something back outside. All right? So that's what's going on here. That's why these are all correct. Entities cannot talk to other entities, though. They have to go through the system. Entities also can't talk directly to data stores. There has to be something that pulls information from the entity and puts it into a data store, or in this case, something that pulls it from a data store and pushes it to the bank. Notice too, by the way, that entities don't have to be people, right? Like bank is just something that exists outside the system. All right, so that was sort of a great lomping through some little bits of it, but let's actually have a look at an actual diagram. So when you create a set of DFDs, the first thing you're going to do is you're going to create what's called a context diagram. And that's sort of the highest level. And then after that, we start decomposing it, right? And what happens at every time, by the way, what you're supposed to do with these DFDs is go and talk to like business analysts or your stakeholders and make sure that this is actually right. So we're going to draw basically a context diagram. It fits on one page. It's basically got, you're going to see it in a minute, but it's got the name of the system and then all the entities and data flows that come in and out of the system. So I'll let you read all that, but this is basically a context. So now you can kind of see a little bit of what's going on. So the context is basically the name of the system with a 0. All processes, by the way, have to have a number. And so in this case, this guy is 0. It's got the entities, and it's got the data flows. And you can see what the order is. This is basically modeling in your system the input and output requirements that we talked about last chapter, right? So this is basically all the inputs and outputs. So like a student will receive a final grade, that would be an output requirement. A student submits homework into D2L, that would be an input requirement. So these are basically the input and output requirements of the system. And this diagram, initially a new person might look at that going, well, what is the point? The point here is that you now know what the border and scope of the system is. That's what the point is. So we know, for example, that at no point does this system ever talk to the cafeteria, because the cafeteria is outside the system. It's not modeled here. All right. So so this basically describes who is being involved with the system and what. And I say who, by the way, I understand that who could be systems as well as people, but who is interfacing with the system and what are they actually getting from or supplying to the system. So that's what that one's about. Now, a context diagram has its uses, but at some point you're actually gonna need to go and explode this 0 and decompose it to basically find out what are the processes inside there. But not yet, I guess, because first we're going to look at this. So this again, step 1, a context diagram. So it's yet another context diagram. Name of the system with a 0, all the things that interface with the system, with their data flows. And again, it does say a lot of information here. Like for example, we know that our system will push things to the bank. We're apparently not going to be pulling anything from the bank. That's a very important piece of information to know at this point, because there could be a lot of stuff involved with a pull, not necessarily as much with a push. So so this diagram is actually pretty useful. So from this, we start going to a level 0. Now this is called a diagram 0 because what you've done is you've taken the 0 process and you've exploded it to all the things that will be in that level 0. So first thing you're going to note is that the entities should be the same at this level, at level 0, right? So we should see a customer, warehouse, accounting, bank, and sales rep. Here we're seeing customer, warehouse, accounting, bank, and notice they say sales department. This is actually a mistake, right? What should happen to balance these two diagrams as we go from the parent to the child, if the parent has got these entities, the child should have these entities. So that's actually a good example of how not to do it. The other thing you should be seeing is that the data flows that come from customer, order, reject, invoice, payment, you should see order, reject, invoice, payment in exactly the same flows too. The order is a push, reject is a pull, invoice is a pull, payment's a push. So push, pull, pull, push. So what you're seeing now is these are the processes that go together to make the order system. So it apparently will fill the order, create the invoice, apply the payment. That's how, and by the way, that functional decomposition diagram would have been a good one here to show too, where you see that these are the actual processes that make up that particular system. And we don't know how an order is filled or how the invoice is created or how the payment is applied, but we basically do know that those are the 3 steps it takes to basically get an order to all the various things that need to get that order. We also know it's not instantaneous. Something here is remembering it. So we get this order, it gets filled. I guess they go to the warehouse, get some stuff, the order is completed. And then once we get the order done, well, someone's got to pay for it. So the invoice goes both back to the customer and it gets stored here. And then once they start paying, the payment guys pull the invoice, they get the payment, somebody gets some money there, some deposit happens there, and I guess we get accounts receivable. We'll take it from there. So that's not too bad. All right, so again, this is called level 0 because what we've done is we've taken this 0 and broken it down to these processes. So that's why it's called level 0. Now, that is okay, but now we got to break down further. So if we look at fill order, it apparently takes 3 steps to fill an order. And notice decimalization happening now, 1.1, 1.2, 1.3. These are the 3 steps it takes to fill an order. Notice that fill order only talks with customer and warehouse. So we see customer and warehouse are the 2 that are talked to. Notice that fill order doesn't have any data stores, but inside it's using data stores. So these are data stores here, I guess, used to remember its customers and products. So the reason there's a data store here is that this data store interfaces with 2 processes. If you have a process that's only going to be in one data store, if you have a data store that's only going to be in one process, it's going to be basically inside the bubble. So again, this is the child, and this would actually be called a level 1. I want to be careful with this because if this was create invoice and we exploded it, that would also be level 1. This would also be level 1. And then later, if you exploded this guy, verify order into sub-processes, that would be called a level 2. I always like to think of it as how many decimals are after here. So if there are 2 decimals, it's going to be a level 2. If there are 3 decimals, it's going to be a level 3. Now, the whole point of this is to drill down in this until you get to what's called a functional primitive, and that's what this bullet point down here is. You want to keep going until you get to the functional primitive. Like what is the easiest possible, like almost a 1 or 2 liner thing as to how a verify order would be done. All right. Now, what they are saying here is that sometimes you don't necessarily have to, like notice what's missing here, customer and warehouse. Sometimes you can leave those off as you're going to lower levels. That's what they're basically saying there. Okay, so again, this is sort of another example of in this case, what they've done is they've taken apply payment and they've exploded it to be what apply payment would take. And again, notice we get the balancing here of accounting, bank, and sales debt. And they again did the exact same mistake, by the way. It's not balancing correct here. But anyway, they do have accounting, bank, and customer. How does it? Oh yeah, of course it gets a payment from the customer, and then it's accessing the outer data store, and there's an internal data store there. neat stuff there. Now, as far as how to create them, they're going to show you a visual analyst way. I would suggest to you guys that you can do it that way. Visio also has a template for this. PowerPoint, in all honesty, is how I've done it as well. Something I played with called Oracle Data Modeler that also has the ability to create data flow diagrams. So you'll have several options available to you. Worst one is Paint, by the way, but I have seen people do it in Paint. So anyway, I think that's pretty well the worst one. I think the second worst one is doing it in Word, but Paint was definitely the worst one. So these things, before I leave this topic, there's one sort of subtopic, and that is the data dictionary. Typically, the data flow and the data store, you're going to want to further define what actually is that data, and so that's what the data dictionary is used here for. It's designed to sort of kind of capture what is the element, like what actually is the smallest piece of data, like an order number, for example. How big can an order number be? What does it mean if there's any kind of inherent meaning in the order number? And then a record would be a collection of stuff. So, for example, an order would likely have the order number, the date, the customer number, some stuff like that. So in your programming classes, I hope that you've encountered these things. A record is a data structure, and later in the world of databases could transform and become a row, but that's for another topic. And of course, we can use various case tools, like I've mentioned before. Remember, CASE is computer-assisted software engineering, I think. So, and I brought some of them up before. I think to give an example, there's sort of an example right there of some tool that's basically used to help define the data dictionary. Other things too, by the way, are validity rules. We'll talk about this a lot more when we're talking about user interfaces, but and actually databases. But all those start with someone actually understanding what is valid. Like, can an order number be negative, for example? Maybe it can, right? But if it can't, this is the best time to say that. Order numbers can't be negative. Order numbers have to be between, 1111 and 9999 or something like that. Who can actually see the order number? That would be another one. For example, if there's salaries, if we were looking at human resource salaries, there would be definitely some security around that. And so it's not just an issue of basic data type stuff. There is definitely logic that you can basically put there as some kind of rules. And so anyway, so that's what they're talking about there. And so here, more and more stuff about data dictionaries, and I'll just let you look at those. And we're about to talk about documenting an actual process, but I think I'm going to save that for, I'm going to save that for a bit later. These systems, by the way, when you're using like a case system or case product, there can be reports that basically come out. I got to say, I used to look at reams and reams of paper, and now, of course, a lot of this stuff gets transformed more into, in my case, Confluence, but I suspect SharePoint or any of these kind of products that basically allow you to look stuff up. Also, by the way, with data flows and data stores or data in general, sometimes they're owners of that actual data, and they, of course, are the experts of what an order is. You'll want to be friends with them if you're actually working with this stuff. All right. So now I'm going to break this video, and then I'll resume later and talk about processes.